Now, one of the important aspect of the arc welding process, that the how to decides or how to design the power sources for different welding processes. So, there definitely there is a requirement of a power source to deliver the controllable current and voltage according to the welding process used. So, we know that specifically in welding process, the power source is used in such a way that high amount of the current and the low voltage, basically low voltage in the sense that around current range may be more than 100 amps and voltage is around 20 volt. So, as compared to the normal electrical connection. So, but this requirement for this requirement specifically used for the welding process needs to develop the different power sources, but there is another aspects also that during the process or when you create the arcs and to maintain the arc and to continue the welding process over the time. So, in that case two different characteristics of the power source can be defined. So, one is the constant current source, or other way it is also called the falling characteristic power source, and second one is that constant voltage or flat characteristic power source. So, these two different type of the power source, how the current or voltage can be adjusted during the welding process when we use some consumable electrode or normal electrode, or in the process if there is some change in the arc length, or if there is a presence of any agents or maybe surface oxides layers present in that workpiece surface, that actually tends to make some variation in the either welding current or voltage. So, based on this, the applicability of the power source in welding process is defined basically in these two categorization. Let us see that first one is that constant voltage power source. What are the typical characteristics of this type of power source and why it is required? First thing, if we look into that, this type of power source can be used in case of semi-automatic arc welding process. That means, in semi-arc welding automatic arc welding process, there is a probability of variation of any voltage or current relatively small, since it is automated process as compared to the any kind of manual process. So, in that case the typically downward negative slope type of characteristic. So, that characteristics define the relation between the voltage and current. If you see from the figure that voltage and current it's follow almost linear, or in other way we can say it is a almost flat characteristic of the power source, that means relation between the linear relation between the voltage and current. So, this type of power source is characterized by that first is the sufficient internal electrical resistance and inductance in the circuit. So, that there is a small change in the current, probably there may be the changes accordingly, there may be the try to maintain the almost constant voltage by changing the current. So, change in current is accompanied by the process is basically the melt the electrode at the required rate. So, the sense of change in current is basically reflected by melting the electrode, so that it will try to maintain the constant voltage of the power source. Speed of electron as well also control the average welding current, and constant electrode wire feed basically is the self regulating or self adjusting, creates the self adjusting arc length of the system. So, in this case the preset always try to maintain the desired arc length by maintaining the constant voltage, but if during the process if there is a small variation of the change in the arc length, that is automatically adjusted by melting the electrode material, definitely in case of the consumable electrode. So, any change in the welding current occurs, in this case it automatically increase or decrease the electrode melting to regain the desired arc length. So, to maintain the desired arc length, it is also to maintain the constant voltage power source. So, figure if you see that from the figure that it starts from the open circuit voltage. So, that open circuit voltage is required when just to start the arc welding process, and then from the open circuit voltage there is a drop, but drop rate is very low in this case, and of course, it is a negative slope, and that actually desirable characteristic of the constant voltage power source, and of course, it is more suitable for the automation of the arc welding process. So, if you look into the another type of the power source, that is constant current power source. In this case, we can see from the figure the relation between the voltage and current can be represented like that. It is a non-linear way, and there is a sharp dropping of the voltage with a small change in the current. So, that is called the sharply dropping characteristic of the power source. So, definitely in this case during the welding process it is always tried to maintain the constant current, but by accordingly by changing the voltage. So, this type of power source is very typically useful in case of manual arc welding process. If we look into the manual arc welding process, it starts with the by sticking of the arc, that means by sticking of the arc, that means open circuit voltage is very high, and then after that, after sticking of the arc, then we will after that we try to maintain the constant arc between the workpiece or electrode. But manually it is not very easy to maintain always the constant arc. So, there is a highly chance of the desirable that there is maybe the continuous change in the arc load. So, that is accommodated by this type of typical characteristic power source. Now, if we look into that, definitely the high frequency unit supplies the high voltage, and along with the high frequency with low current. So, initially when you try to create the arc, that ionizes the medium between the electrode and the workpiece material, and so that it starts the pilot arc, which ultimately leads to the start of the main arc. So, to maintain a change in the to maintain this type of arc welding process, or to create the arc, it should follow this type of typical characteristic of the power source, that starts with the very high open circuit voltage, and then the drop of the voltage is actually occurs in rapidly, and that follow very nonlinear path, and also it is a sharply dropping characteristic it follow in this case. So, this type of power source is basically desirable of the manual arc welding process, and it reflects that in change in the power source, that means open circuit voltage, adjust and out and also control the output current, and that basically represented by the change of the slope, that represented by the change of the slope in this volt versus ampere characteristic graph of this type of power source. So, here you can see that two types of the power source, one is the constant voltage, another is the constant current. So, one is suitable for the manual arc welding process, that is the constant current power source is suitable for manual arc welding process, and another is suitable for the automatic arc welding process, that is the constant voltage power source is suitable for the automatic arc voltage welding. So, basic things is that if we try to sustain the welding process, that means after creating the arc and to maintain the arc gap between the workpiece and electrode, we need, depending upon the application applicability of the whether it is manual or whether it is automatic, based on that power source can be set accordingly. So, apart from this, characteristic power source, we can find out that two different characteristic of the power source, and then we can find out that there is another important phenomena which happens in the welding process, that is the shielding gas. So, basic role of the shielding gas we use in the this shielding gas in the welding process, but the main role is that to protect the molten metal from the contamination of by the outside atmosphere. That is the main objective of using the shielding gas. Now, this is the essential part of the welding process until and unless the welding happens in vacuum. So, if it happens the vacuum, there is no question of the contamination of the molten weld pool or with the atmosphere. So, in that sense, is an almost every welding process normally a different way we can protect the molten pool from the outside atmosphere, and either using the direct using of the shielding gas or in different way. That means, we can create the slag coverage, and that is and by the chemical reaction of the arc that happens during the chemical reaction of the arc. So, these are the two way to different to apply the shielding gas or to protect the molten pool. Now, what are the common shielding gas we use? We have observed that the different type of the shielding gases like argon, helium, carbon, carbon dioxide and oxygen, these are the typical shielding gas is used, but oxygen cannot be used alone, but always we use the oxygen mixing with the other shielding gases. Now, these shielding gases either we can use is 100% the, if you see the shielding gas is mostly the inner type of gas, so that it will try to avoid the make the reaction with the molten pool. That is why argon, helium, these are the typical type of shielding gas we use during the welding process. First, either the shielding gas, individual shielding gas can be used alone, 100% of the shielding gas can be used in the for certain applications, or sometimes we use the mixture of the two different or more different shielding gases for with different combination to get the certain advantage. But the basic role of the shielding gas or basic principle of the shielding gas actually relates to the reactivity, or shielding gas can be decided based on the reactivity of this shielding gas with the molten pool or maybe during that high temperature environment, and what is the ionization potential of this type of shielding gas, that means how easily it can be ionized or not, and what are the thermal conductivity of the this type of gas or thermal conductivity of the workpiece materials. That also play important, these factors also play important role to choose the shielding gas. But basic point of choosing the shielding gas is that based on the whether it is very reactive with the at high temperature environment or not, or if whether by reacting with the workpiece material, substrate material, whether it can produce some defect in the welded joint or not. So, based on that we can choose the different type of the shielding gas. Now, these are the basic role of the shielding gas. Now, we will try to discuss the some overall idea or in general different fusion welding processes. So, these fusion welding processes we know that it is a broadly categorized this welding processes, that fusion welding processes, non-pressure, that means without the application of the any pressure, or pressure welding, that non-fusion. So, without using any without, that means pressure welding, there is no fusion of the substrate material. So, but we will focus on the only on the fusion welding processes, some general idea about the fusion welding processes. So, that fusion welding is basically we can categorize in this way, that gas welding, a name of the different gas welding processes, that is oxy-acetylene, acetylene, oxy-hydrogen. So, basically chemical sources by burning these gases, that this can produce the heat, and that heat can be used to fuse the to melt the material. So, these are the typical gas welding process we have used for joining of the metallic materials. High energy beam. So, if we look into that high energy beam welding processes, normally the electron beam welding process and laser beam welding process are two widely used the high energy beam welding processes. Third is the chemical based, that thermite welding. So, in that case some oxides is used, and during the reaction it generates the heat, and that heat is basically try to fuse the material. So, that is called the welding process, that is chemical based welding process. The one example of this thing is the thermite welding process. And apart from this, other typical usable welding processes, that is arc welding process. So, arc welding process, in this case the categorized in the following way, that using the consumable electrode or using non-consumable electrode. So, consumable electrode, the electrode can be consumed during the welding process, and it becomes the final part of the weld joint. So, consumable electrode, we can find out that shielded metal arc welding process, that is SMAW process mostly used, GMAW gas metal arc welding process, submerged arc welding process, and electroslag welding process. These are the most general the consumable electrode arc welding processes. And if we look into that non-consumable electrode, that is the gas tungsten arc welding process, plasma arc welding process, and carbon arc welding process. These are the typical non-consumable electrode process, but of course, it is a non-consumable electrode process. That means, in the sense that main electrode which creates the arc between the workpiece and the electrode material. So, in this case that electrode material is non-consumable, but it is possible to use some extra material that can be melt during the creation of the arc between the workpiece and the non-consumable electrode, and that extra material becomes the final part of the weld joint, and in this way that using the filler metals, the non-consumable electrode arc welding process can also be developed. For example, in case of gas tungsten arc welding, sometimes we use the extra filler material in this case, but the main electrode is not consumable in this case. In that sense, it is called the non-consumable electrode arc welding process. So, with this fusion welding processes, we will try to give an overview of all these type of fusion welding processes. Although in the very conventional courses, this already covered, but I am try to give some basic idea about all these processes. So, first we will start with the oxy-acetylene gas welding process. So, oxy-acetylene is a gas welding process. So, basically the mixing of the oxygen and acetylene, and the different way means in the different proportionate between oxygen and acetylene, they can produce the varieties of the envelope of the flame, and that temperature actually depends temperature of this flame depends on the what ratio we are mixing between the acetylene and oxygen. Let us see that the proportional of the gases that actually decide the nature of the flame. First we look into the natural flame. So, in this case oxygen and acetylene is mixed in such a way that almost 1 to 1, and in this case if we see from the figure the typical nature of the flame, that actually produce some inner cone and outer envelope during the welding process. So, that probably that outer envelope here actually try to protect the heated zone from the little bit heated zone from the outside atmosphere, and inner cone actually supply the try to melt the molten material. So, in this case if you see that welding of the mild steel, welding of the stainless steel, copper, aluminum, all these type of materials can be welded using the simple gas welding processes. And here natural flame in that sense that we assume the proper mixing of the oxygen and acetylene can happens here also, and depending of the nature of the flame, the applicability of the to different material process actually can be decided. Second one is that carburizing flame. In this case, the proportion of the acetylene in the mixture is higher than that the required to produce the with reference to the neutral flame. So, that means the acetylene part is more in this case and oxygen part is less in this case with reference to the neutral flame. So, definitely it can be assumed that the absence of oxygen, that can be say that there may be some unburned acetylene in this case. So, for this case sufficient burning does not occur. So, it can produce the low temperature with respect to the neutral flame, and at the same time it can create some excess carbon can be created. So, typical application of the neutral flame, we can see that welding of the iron and steel, and since excess carbon always produce the hard brittle iron carbide. So, if there is a requirement of producing the iron carbide, in that case the use of the carburizing flame is more preferable, but the maximum temperature is lower than that of the neutral flame in this case. And if you look into this figure, the envelope of the flame is like 3 different, it can create the 3 different envelope. So, you see the inner cone and outer envelope, but here if you see the apart from the inner cone, 2 outer envelope also created, and that can be created due to the nature of the mixing ratio between the oxygen and acetylene. So, third one is the oxidizing flame. So, here if you see the oxidizing flame means in this case the oxygen amount will be the more, and that with reference to the neutral flame. So, in this case definitely since oxygen amount is more, so in this case the temperature will be the more with respect to the neutral flame, and here you can see that from the picture we can see also that apart from the inner cone there is a outer envelope, and that outer envelope is basically smaller and narrower as compared to the neutral flame. So, this type of flame is used when there is a high amount of the heat is required, for example, highly conductive metal like copper based metals, and can also be used in case of the zinc based metals. So, this is the very basic types of the gas welding process. Now, we will try to look into the other welding processes, that is called the sheet metal arc welding process. So, it is well known that sheet metal arc welding process, but here we are trying to focus on the some typical characteristics of this welding process. First is that definitely sheet metal arc welding process is most commonly used, and we can see this welding process is used in the definitely in the construction side also. So, first thing we can see that consumable electrode can be used in this case, but if we see precisely look into the electrode is coated with some flux. So, purpose of using this coated flux, that actually try to produce the protective gas around the weld, and then it actually helps to protect this molten pool from the atmosphere by creating the outside creating the protective gas, and finally it creates the produce the slag layer of the one slag that is in weight, that is lighter as compared to the molten material or maybe as compared to the base material. So, that lighter metal becomes on the top surface, and that creates the layer of the slag layer. So, that slag layer also other way until unless it becomes cooled down, it also against the protects the this molten material during the solidification process. So, in that case it is very much advantageous to use the in the different way. Basically, it is a electrode is basically supplying the extra material, at the same time it is also protecting the weld zone during the welding process or as well as during the solidification process also. So, if you look into that figure, there is a power supply and it completes the electrical circuit, and between the workpiece and the electrode it creates the arc, and the arc is basically surrounded by the protective gas, and that protective gas actually creates from the coating of the flux coating over the electrode. And then if you see the solidified metal, over the solidified metal there is a slag layer. So, after finishing the welding process it is necessary to remove the slag layer. So, these are the very well known and very stable welding process, and we use most of the cases. But here the choice of the electrodes depends because electrode material is also important factor here, what type of material we are trying to weld and what is the choice can be done according to the metallurgical compatibility of the electrode material to the base material. Based on that we can choose the different types of the electrode material. In simple way, what are the advantage of this process? It is a very simple process, and mostly this process is used manually. It is a very simple portable equipment and the not very costly equipment as compared to the other welding processes. But if you look into the limitation of this process or disadvantage of this process is that it is a discontinuous process, because the length of the electrode is limited. So, there is a not continuous supply of the electrode. So, once the electrode is length of electrode is over, then it process become discontinued, and we have to feed next we need to feed the another electrode, and then we can continue the process. So, that is the one limitation. Second, the oil metal content, also the slag inclusion, because it is a during this high temperature phenomena molten metal may contain some amount of the slag material may also remain within this zone. So, that is also another disadvantage, and because during the welding process it creates the protective gas, and that is that's why it is very difficult to make it as a make the process control. So, in that sense this process this process is not converted to the automatic process, rather that is why this process is mostly used for the manual process. Second, we will look into the other welding process, that is gas metal arc welding process. So, with reference to that shielded metal arc welding process, in gas metal arc welding process, here apart from this we can use a continuous supply of the electrode material. So, that electrode is basically the electrode is used is a continuous wire, and that is wounded in the other places, and it is externally or separately it is supplied to the process continuously. So, in that sense it is we can say that it is a continuous process as compared to the shielded metal arc welding process. So, definitely gas metal arc welding process we use the consumable electrode, and in this case we generally not use the flux, but directly we can use the shielding gas here to protect the molten pool. So, shielding gas like argon, helium, carbon dioxide, or mixing of argon, oxygen or any other gas mixture is normally used for gas metal arc welding process, but commercially we generally use in gas metal arc welding process for welding of the steels. Normally carbon dioxide can be used, because carbon dioxide is cheaper as compared to the other inert type of shielding gas. So, if we look into the process, that it also create the electrical circuit, that the arc is created between the electrode and the workpiece, and here if you see there is a apart this along with the supply of the consumable electrode over some drive rolls, at the same times there is a supply of the shielding gas used through the same nozzle. So, that shielding gas actually protect the molten pool thing, and normally copper nozzle is used here, and this wire sometimes use either the electrode wire is either is a solid or solid wire definitely used, and sometimes it is also used in the form of the some coating may be done over the solid wire. So, this process, if we very precisely look into what are the advantages of this process, we can find out that it is a continuous welding process, no interruption like sealed metal arc welding process, and of course, another advantage is that it is not necessary to remove the slag. So, slag after the finishing of the welding process, slag removal is not required. So, that is why in this way this gas metal arc welding process is possibly can be automated as in that automated, and in that sense it is advantageous as compared to the sealed metal arc welding process. But if we look into the disadvantage in general, that it is a definitely expensive as compared to the sealed metal arc welding process, because it is also necessary to drive the electrode material according to the consumption rate, or that should be adjusted to the consumption rate during the welding process. So, in that way the equipment is a little bit expensive as compared to the sealed metal arc welding process. Then we look one of the most widely used welding process, that is submerged arc welding processes. In this case also we use the consumable wire electrode, and but the difference is that shielding is actually provided not by the shielding gas, it is a provided by the granules of the flux is used. In this case, if we look into this picture, though like gas metal arc welding process, here also some drive roll is there, and that actually supply the drive roll is basically control the consumable electrode, and but the shielding is happen using the flux granules, and this low, and it produce the low ultraviolet radiation and also fumes as compared to the shielded metal arc welding process. And flux actually acts as the thermal insulator and suitable for the this process is mainly suitable for the very thick material. So, it is a large volume of the welding is required. So, in that case submerged arc welding is a good choice of that. So, submerged arc welding process also developed in that not only the single wire, twin wire, two wires can be used also. So, instead of single wire. So, it is a kind of taking the advantage of the submerged arc welding process, combining these things, that both shielded metal arc welding process. So, using the flux and takes the advantage from the gas metal arc welding process. So, here we use the consumable electrode, but in the form of the wire. And here if you see similar electrical circuit is produced between the consumable electrode and the workpiece, but the huge flux actually covered the weld zone. So, that is since the flux granules cover the weld zone. So, in this case the efficiency of the process is relatively higher as compared to the arc welding or sealed metal gas metal arc welding or sealed metal arc welding processes. But if we look into that, typical advantages that it is a very high welding rate. So, as compared to the sealed metal arc gas metal arc welding or sealed metal arc welding process. And this process is basically it is possible to do the suitable for the automation, or it can be converted to the automatic system, and high quality weld structure is can be produced, and main advantage is the efficiency of this process is very high as compared to the gas metal arc welding or sealed metal arc welding processes. Or at the same time the very high welding rate can also be done using the twin wire also. Then two wires can also be used in this process to get this, to improve the rate of the welding process or material deposition process. And of course, this process is designed or developed specifically for the or suitable specifically for the when there is a requirement of the very high thickness or large volume of the material, but also having some disadvantages, that weld may contains the as in general other processes also, that it contains the slag inclusion within the weld zone also, and mostly used for the or suitable for the horizontally located plate. So, these are the two typical disadvantages of this process. And now, we look into that electroslag welding process. So, in this process the workpiece is filled with the welding flux. If you see the welding flux, and but at the start the arc is created to melt the flux powder, and that actually forms the molten pool, and then after that heat is generated, due to the molten flux becomes short circuit the arc, and then heat is generated due to the ohmic heating of the slag. So, then slag circulates and the molten circulates within the zone, and the melt the consumable electrode, and basically finally it is join the workpiece edges. So, if we look into this figure, that we use the electrode wire and the power supply, that means to make is the electrical circuit, the guide tube also there, and that actually wire, electrode and guide tubes, the flux making this thing and produce the molten. This in this case the advantage is that it produces the molten slag, and then indirectly that molten slag is actually produces the weld pool. So, in this case if we look into the main advantage of this, that high deposition rate is possible, even also welding of the very thick plates also possible. The slag consumption rate is typically low, and low distortion is possible in these processes. That means, the electroslag welding processes is almost the similar kind of advantage of the submerged arc welding process. But if you look into the other aspects, this thing, the disadvantage point of this thing, first point is that this process can be done only over the in the design specifically for joining of the in the vertical position of the plates. Basically, when you keep the vertical position of the plate, and then keeping two plates as a vertical position, and then from the bottom plate we just keep on welding, and the electrode is basically simply keeping upward direction, and then upward direction, and consequently it make the welding in the back side. So, that this process is specifically advantageous for joining of the two vertical plate, and in the large scale, that means large volume of the molten pool is required. In this case, this process is more suitable. So, apart from the electroslag welding process also, there are other welding process, that is the most simple welding process, that is called the carbon arc welding process. It is a very oldest welding process. Seals may be used for the weld pool protection depending upon the type of the melter. So, shielding can be used also, that means either natural gas or flux can be used in these processes, but the basic principle of this process is that power same as the other welding processes, the workpiece power supply, the arc is created between the workpiece and the electrode using the non-consumable carbon electrode, and it produces the weld pool. And in this case, if you see that non-consumable carbon electrode is basically used, and that this process has been developed long before than the other processes. So, but if we typically look into the advantages of this process, is the first is that low cost of the equipment. So, simply you can use the non-consumable carbon electrode, and shielding can also be done either flux or maybe we can use the natural glass. So, in this process, that is one of the advantage is that low cost of the equipment, and therefore, not required very high operator skill is not required, and these processes can be easily automated but because this process is not very complicated and low distortion of the workpiece can also be achieved. Since this is one of the oldest welding process, so that it is a very simplified way can be applied, but definitely if we look into the very precision of the welding process, in the sense less defect and other way try to produce the less amount of the defects, probably then looking into that aspect, the other welding processes has been better choice as compared to the carbon arc welding process. But precisely looking into the disadvantage of this process, that is that mainly the quality of the weld joint. So, in terms of that, it is not suitable for the, when you try to expect the high quality welding joint processes as is already there. But one point is that the carbon of the electrode actually contaminates the weld material with making the formation of the carbides, because since carbon is acting as an electrode. So, at high temperature there may be the possibility of the transfer of the carbon atom, and that creates the carbides in the workpiece material. So, if it is the requirement of to produce the any carbides on the workpiece material, probably in that sense this welding process is more suitable as compared to the other welding processes. Now, the most usable, another one of the most usable welding process, that is gas tungsten arc welding process. In this process we use that non-consumable electrode, and of course non-consumable electrode, but with or without any extra filler material can be added in this process, and sealing is done generally argon, helium or nitrogen, that means one type of the inert type of the gas, and specifically used for this process when it is a very thin section or very small weld joint is required. In this case, the gas tungsten arc welding is a good solution. Now, if you look into this, from the figure, that power supply is similar to other welding processes. Between the arc can be created between the non-consumable electrode and the workpiece material. Shielding gas is required, and the filler rod may or may not be used depending upon the application. So, the non-consumable stuck through the along with the non-consumable electrode, that there is a the passes through the nozzle, and the also the shielding gas also passes through the nozzle. So, this is the maybe without using the any kind of using the non consumable electrode, this is the one of the most simple simplified welding process, but more usable welding process, in the sense that it is having the typical advantages, that since there is no need of using some consumable electrode, or if there is no need of use any filler material. So, only by supplying the heat and fusing these two material. So, material composition is almost close to that of the parent material, but of course, the nature of the solidification behavior of the specific material, that may be bring some structurally different from the base material, but composition may be the same. Relatively high quality welded structure can be possible. So, no slag formation as compared to the other welding process, since we are using only the shielding gas, and it may not become part of the final weld joint. So, thermal distortion of the workpiece can be minimized, because the heat can be concentrated in a very small zone as compared to the consumable electrode like gas metal arc welding or shielded metal arc welding process. So, in general, the shielded metal arc welding or gas metal arc welding process, definitely the concentration of heat depends on the size of the electrode, but in that sense the size of the electrode can be controlled in case of gas tungsten arc welding process, that can be done the different shape of the nozzle tip, and accordingly heat can be concentrated, and of course, in other it also depends on the shielding gas flow rate also. So, in that point of view, that the gas tungsten arc welding process is one of the most widely used welding process, specifically when you try to join is a very thin metal, and there is no need of any filler material. But disadvantage is that low melting rate as compared to the other welding when there is using some consumable electrode, relatively expensive as compared to the I can say that carbon arc welding processes, and it also requires high level of the operator skill. That means, to maintain the arc gap or to move the torch, then high operating skill is required to get the successful weld job from these processes. So, apart from gas tungsten arc welding process, we can look into the other aspects of the gas tungsten arc welding process. One thing is that workpiece in a protective inert gas, workpiece remains in the protective gas atmosphere, and next is the any filler material is used which can be used externally. So, there may or may not be required any filler metal, or maybe filler metal may not be the part of the main welding system. Sometimes to increase the melting rate, melting point of the electrode. So, that since in this process we use the non-consumable electrode, its objective may be to increase the melting point of the electrode, and that can be done using the thorium or zirconium is added to the tungstens, that actually that is basically useful or helpful to retain the high hot hardness even at very high temperature. So, in that case we generally use 2% thoriated tungsten electrode in gas tungsten arc welding process. Just because of that, for this material the melting point is very high, so that it will try to reduce the wear of the electrode at the very high temperature or melting of the electrode. But in the when you try to look into the that we can see that is the electrical circuit is there, power supply, and then here workpiece, and that it creates the circuit. So, whether the electrode, what should be the polarity of the electrode, that can also be changed in gas tungsten arc welding process. Normally DCEN, that means direct current electrode negative, is used in this case, but of course, depending upon the application, direct current electrode positive can also be used, or AC current can be used instead of the only of the DC current. Normally welding of the aluminum and magnesium and their alloy, normally AC current is preferred, because alternative current is make the cleaning action in the half of the cycle during the welding of this material. So, there is a continuous change of the polarity positive and negative when we use the AC current. But typical point of this process is the most usually shielding gas is the argon material, but sometimes use the nitrogen for welding of the copper material. So, these are the typical characteristic or typical points that is related to the gas tungsten arc welding process. Now, we look back to the another arc welding process, that is called the plasma arc welding process. Here if you see that plasma arc welding process, it is always try to take the advantage of the gas metal arc welding process, almost similar configuration. That means, they use the non-consumable electrode, creates the electrical circuit, but here we can use the another extra shielding gas, that is called the plasma gas, basically that actually creates the arc and maintains the arc, and that actually helps to melt the workpiece material. So, with respect to the gas tungsten arc welding process and all the general components of the gas tungsten arc welding process, here the addition of the extra plasma shielding gas. But let us look into this figure, how this process has been developed, the plasma arc welding process. Here we can use the DC power supply and create the positive and negative, and here non-consumable tungsten electrode we can use here, and shielding gas also supplied, but inside there is a plasma gas also be supplied here. So, basically passing through the electrode, there is the current when passes through the electrode, it creates the pilot arc, and then after that it creates the arc due to the passing of the plasma gas, and then high temperature has been created, and finally it creates the plasma arc between the nozzle tip and the workpiece material. So, what is the advantage of with respect to the gas tungsten arc welding process in case of plasma arc welding process? In general, the position of the electrode or torch of this plasma arc welding process can be designed in such a way that it can produce the very constricted arc as compared to the gas tungsten arc welding process. Because gas tungsten arc welding process, the arc is created between the workpiece and the electrode tip of the electrode. So, depending upon the tip of the electrode, the shape of the arc can be decided mainly, but in this case the apart from the electrode tip, there is the plasma gas is the main gas that actually creates the arc between the workpiece. So, that plasma gas, application of the plasma gas can be constricted in a very small zone. So, that is why very constricted arc can be created using the plasma arc welding process. So, even from on the other welding on the arc welding process, only in the plasma arc welding process it is possible to produce the keyhole mode, that means high depth of penetration can be welded using the keyhole mode plasma arc welding process. So, here if we look into that typical points of this arc welding process, first is the what is the plasma? Plasma is the basically gaseous mixture of positive ions, electron and neutral gas molecules, and that plasma gas is actually create the arc between the workpiece and electrode material. And here also like GTAW, here we use the non consumable electrode, but specific advantage is that it is a good tolerance of the arc to misalignments. If there is a misalignment, it can be adjusted by the creation of the arc, and high welding rate can also be done in plasma, and keyhole effect can also be produced. This is the only arc welding process where keyhole mode effect can be produced, and that actually penetrate is the high penetrate in the for high thickness material. So, these are the typical advantage, but other advantage of these things, plasma arc welding can also be nowadays the plasma arc welding can also be developed in the microplasma range, in the sense that is called microplasma arc welding processes. So, such that the electrode current that welding current can also be reduced to less than 10 amperes, and even it is can be controlled even for the in the range of the milliampere. So, with this controlled arc, with this controlled current, the arc can also be controlled in even in the module of the pulse or continuous mode, and that small amount of the application of the current here, that means indirectly it is basically it can control the heat input, and that heat input can be created in a very small way, small amount, that may be suitable for the any kind of micro welding processes. So, that development has been done also in plasma arc welding processes. That is the another advantage of this process, you can say. But in terms of the disadvantage, that expensive equipment as compared to the other welding process, that of course, the expensive equipment is a relative term here. Probably this is expensive equipment as compared to the gas tungsten arc welding process. But high distortion and wide weld as a result of the high input. If there is a requirement of the high input, then it can produce the high distortion, and maybe wider weld pool can also be produced. But the width of the weld pool is more controllable in plasma arc welding process as compared to the gas tungsten arc welding process. Now, normally plasma arc welding process, two modes of the plasma arc can be used in the arc welding process. One is the transferred arc, another is the non-transferred arc. So, transferred arc means it is a simple way the creating the arc between the workpiece and the electrode material. So, that workpiece being welded, and it becomes the final part of the electrical circuit. Plasma arc transfers from the electrode arc, basically arc creates or arc transfer from the electrode to the workpiece material, and that can be done is a very high speed of welding. So, this is the normal mode of the plasma arc welding process, that is that we say that transferred arc, it is like a gas tungsten arc welding process. It is a simple way the creating the arc between the workpiece and the electrode, but other way also it can also be developed, or it is developed in the another mode of the electro arc welding, that is called the non-transferred arc. So, non-transferred arc is basically arc can be created between the electrode and the nozzle. So, basically nozzles becomes the part of the electrical circuit here to complete, and that generate the heat. That heat can be the heat can basically creates the molten of the workpiece material. So, in this non-transferred arc, basically high temperature is carried out to the workpiece by the plasma gas, and this is in this case the thermal energy transfer mechanism is basically like the almost similar to the oxy fuel, where mode of in oxy fuel welding process, or maybe oxy fuel transfer of the in oxy fuel welding process, what way it transfer the or it generates the heat. So, basically the non-transfer arc is mainly used for the welding of the various materials, but it is a can be used as a for the thermal spraying or making the coating of the surface. This non-transfer arc is more preferable. So, that is why this is another development of the plasma arc welding process. So, using the non-transfer arc basically create the coating process than welding processes. So, laser beam welding process, this is one of the most precisely controlled heat source process and use, and when there is a requirement of the very precision, that means limited amount of the molten zone, heat affected zone, then this is one of the best solution, that means using the laser beam welding process. Let us see the laser beam welding process. So, generation of the laser, all these things, that is the physics of the laser, that can be explained or in the different module, but knowing all this fact about the laser, we can say that in this case the laser beam welding is mainly advantageous to produce the high depth of penetration, and it can creates the limited size of the heat affected zone and limited size of the molten pool. That means, aspect ratio between the width and the depth of penetration is relatively more in case of laser welding process as compared to the other arc welding processes. Other point of laser welding process, that it can be used either as conduction mode or keyhole mode welding process, both depending upon the requirement. So, conduction mode welding process means relatively the aspect ratio, that means width and depth of penetration is relatively low as compared to the keyhole mode welding process. So, conduction mode welding process we can get the not much depth of penetration, but high amount of the weld width, but just vice versa in the characteristics of the typical keyhole mode laser welding process, where high depth of penetration and very small amount of the weld depth is produced the keyhole mode welding process. So, depending upon the application, both conduction and keyhole mode laser welding process can also be used. In this, of course, like other arc welding processes, here also the laser beam welding also use the shielding gas to protect the molten pool of the material. But if we look in the typical advantages of all this process, that first is that very narrow weld zone can be obtained using this laser beam welding process, because it is focused on the very small zone, but at the same time the intensity is very high as compared to the arc welding processes. Relatively high quality weld zone can be produced by simply making the usable of the keyhole mode laser welding process. In this case, very small heat affected zone, dissimilar combination of the materials can be welded using the laser welding processes more easily as compared to the arc welding process. And of course, laser welding process is one of the most suitable welding process specifically to design and development of different micro and nano welding process, because laser source can be controlled very precisely. So, taking this advantage, there are the several developments of the micro and nanoscale welding process has been done, where other arc welding process may not be suitable for the micro welding processes. Of course, since we can use the shielding gas also, there is no need of the vacuum in this case like electron beam welding processes, and it can produce the low distortion of the workpiece, since heat is focused on the or in this very narrow zone. That way it can produce the relatively low distortion as other arc welding processes. But if we try to look into certain limitation of this welding process, the one limitation is that the cost of the equipment is very high and as compared to the any other arc welding processes. And of course, it is not completely free from the contamination of the outside atmosphere. Therefore, there is a requirement of the shielding gas even in laser welding processes. So, these are the two limitations of welding processes, and maybe we will try to discuss more about on this laser beam welding processes later on. And next we can look into that another high beam energy welding process, that is called the electron beam welding process. So, in this case, so it creates there is a high beam of the flow of the electrons, and this process definitely it carried out under the vacuum, so that the flow of the beam cannot be affected by the atmosphere, and definitely it also follow the keyhole in this, and that means even the high depth of penetration welding process can be achieved in using the laser beam electron beam welding process as compared to the laser beam welding process. So, if we very precisely look into the different advantages, that deep penetration weld can be produced, and even narrower zone and heat affected zone or narrow weld can be produced as compared to the laser welding process. Very small distortion is the another advantage of this process. Filler material is not required, and another advantage is that electron beam welding process, that the lot of combination of the dissimilar materials can be welded more easily as compared to the other welding processes. But of course, having some disadvantage, in this case it is even more expensive equipment than laser welding process, and very high production cost is also very high. That means, when precision is the main requirement of any kind of welding process, then it is better option. That means, electron beam welding can be used as compared to the other welding processes, but during the electron beam welding process, the secondary scattering, that means X-ray irradiation also happens during the process. So, that needs to protect during the welding process. So, apart from this disadvantage, in general the electron beam welding is normally preferred when there is a requirement of the high precision, it is by compromising the cost of this welding process. Now, other welding processes, we can see that the other type of welding process, that is called the thermite welding process, where the chemical source can be used as a source of the heat. So, basically the generation of heat is mainly controlled by the exothermic chemical reaction between the components of the thermite. Thermite can be defined as a mixture of the metal oxides and aluminum powder. We can look into the example. For example, if you look into this equation, that aluminum and Fe3O4, they react and forms the more Fe, that means pure iron, and that aluminum oxide, that produces the oxide. So, during this reaction it also creates the heat. So, that heat generated is responsible to weld the two different materials, but at the same time that pure iron here becomes the part of the final weld joint. So, therefore, the molten metal produced by the reactions acts as a basically ferrule material joining the workpiece after solidification, and that reaction, since reaction produces the aluminum oxides and free elemental iron and large amount of the heat, and that exothermic reaction occurs is basically reduction and oxidation. So, here aluminum oxide is much less dense. So, that can be separated out from the molten zone, but it is also possible to improve the welding process by sometimes by adding some kind of the other aluminum elements, since the production of the pure iron becomes the final part of the weld joint. So, when you try to join the steel, so that using some adding components can improve the composition of the steel along with the molten pure iron. So, if we look into other type of reaction also in thermite welding, that chemical reaction, other metal oxides can also be used. here to produce the copper. Here also second equation we can see that there is a production of the copper. So, copper or copper based alloy can also be welded using the similar principle. Now, if you look into that advantage of this thermite welding process, we can see that heat of the chemical reaction is basically utilized in this process. Therefore, no need of the extra power source is required, and specifically these large heavy sections can be joined in this process. So, typical application we can see the thermite welding in railway track, the joining of the component using this process. But of course, having the disadvantage that one pointed out that only ferrous, maybe steel, aluminum, nickel materials can be welded, and that means you need to choose the material so that the reaction may happens in such a way that produce the amount of the heat generated can produce the metal, but at the same time the production of the pure iron from the equation we have seen, that becomes a part of the actual welded joint. So, that is why it is having limit combination of the material and the thermite. Relatively slow welding rate. So, the welding rate is not as much as high as compared to the other arc welding processes, but high temperature passes may cause the distortion, and that actually affect the grain structure in the weld zone. Sometimes the weld metals may contain the hydrogen, and also the slag inclusions or contamination is the another difficulties, maybe disadvantage of this welding process. So, in summary of all these welding processes, we can see the few points that is most important points from overall idea of all the different types of the welding processes and their basic structure. First is that heat generation is basically in the electrode, that actually depends on the polarity. So, amount of the heat generated on the workpiece or on the electrode, that depends on the whether we are using the direct current electrode positive or whether we are using the direct current electrode negative. So, when you use the direct current electrode negative, in that case the maximum amount of the heat generated in the workpiece material. So, welding of the highly oxidized material, that means having aluminum oxides. So, where the cleaning action of is most important, in that case AC current, that means alternating current is more preferable. Third point is that thermal conductivity of the material is very important parameter, and that thermal conductivity actually decides, that is the most influencing properties of the material, that actually influence the amount of the fusion zone as well as the more on the what is the amount of the or size of the heat affected zone. So, this dimension of this two heat affected zone fusion zone is mainly depends apart from the other parameters. The main parameter is the thermal conductivity of this specific material. Now, when we discuss about the type or nature of the power source is required for different welding process, in general we can say the flat characteristic of voltage and ampere current curve is suitable for the semi automatic arc welding processes, but on other way the sharp drop characteristics type of the power source is more suitable for the manual arc welding process. So, if we look into the what is the nature of the shielding gas, the inner type of gas is the most preferable choice for the shielding gas. And next is that in plasma arc welding process, the non transport arc is specifically is suitable for the thermal spraying or the in the coating purpose rather than the welding processes, welding of the different materials. And laser beam welding or electron beam welding is mostly preferred when there is a requirement of the high depth of penetration and the minimum heat affected zone and the minimum fusion zone. Definitely this laser beam welding and electron beam welding, they produce the high depth of penetration through the keyhole mode, formation of the keyhole mode welding processes. So, thank you very much for your kind attention. Next we will try to the next part of the this module. Thank you.